Alright, this is lesson 7.1, domain vertical asymptotes. We are still talking about rational functions. Again, a rational function is a fractional, so it looks like a fraction. And so this is the basic form. Numerator over denominator, n, x, and dx are polynomials, so there's x's, x squareds, whatever in those terms. So we're looking at trying to graph or recognize parts of a graph. And over here on the right is a graph of this function, x plus 3 over x minus 2. And you notice that these lines right here, that curve so that there are lines they're called asymptotes. And what an asymptote is that it's a line that these graphs approach but never touch. And the domain of this rational function will include all real numbers except the x values that make the denominator 0. And so that's a very critical part of what we're doing today. And so the value that would make the denominator 0 in this case would be -2, and we figure that out. If you can't easily recognize it, you set the denominator equal to 0 and you solve it. And so the value that makes the denominator 0 is -2. And if we draw that line at x equals -2, if we would draw that line right there, you would notice that these graphs approach it but don't touch that line x equals -2, and that is what's called a vertical asymptote. So right here is your vertical asymptote. And it is at x equals -2, which also happens to be the value that makes the denominator equal 0. Okay. So that's how we figure out these vertical asymptotes. So you're going to always ask for this. You're going to always look at the denominator and ask yourself what makes the denominator equal 0. Now the domain here would be written x is not equal to -2. That's the domain, because it can be everything except what makes the denominator 0. So x is not equal to -2 is the domain. Now if we were doing this in interval notation or set builder notation, it would look like this. In set builder, it would be x such that x is not equal to -2. Okay? In interval notation, which we've gone over before, it'd be -∞ to -2, and we join that with -2 to +∞. Okay? It's a union. And what that does is that's all these numbers except -2, because this curved bracket again means it approaches -2, but it never is -2. So this notation leaves -2 out of the domain, and it's a way to say all real numbers except -2. All right, now looking at these graphs, it says identify the vertical asymptotes of the following graph. So we have to figure out where the line is that these graphs approach but don't touch. And let me undo that. Okay, and that would be this line right here, which is at x equals 1. And so you notice that these vertical asymptotes, vertical lines, have the equation x equals some number. So all vertical asymptotes are going to have the equation x equals 1. If you just put a 1, I'm not going to count it right because it is a line, it's not a point. All right, where's the vertical asymptote on this next graph? Well, if we draw that in there, it's going to be right here on the y-axis. That graph seems to approach but never touch. So that is at x equals 0. Okay? And then we're going to look at this next line right here, and straight down this way, and straight down this way. Okay? So this one has two vertical asymptotes. One of them is at x equals -2, and the other one is at x equals +3. So we've identified the vertical asymptotes on all these graphs. Now let's see if we can figure out which of these equations down here at the bottom of the page match them. Well, again, you're looking at the denominator. So for the equations, you look at the denominator. And I'm going to run out of page. What makes it equal 0? Okay, that's going to be your vertical asymptote. So we'll go back to this equation here. There's just an x in the denominator, so the value that makes it when x equals 0, that denominator will be 0. So the graph that matches that then is graph number 2, because it has the vertical asymptote at x equals 0. Okay? Looking at this one, since there's two factors, if x is equal to 3 or x equals -2, then this denominator here is going to be equal to 0. And so that would match with graph number 3. Okay? And on this last one, it's hard to see because my little 7-1 kind of went over that. But what it is, the equation is 4 over x minus 1. So if x equals 1, then that denominator would be 0, and that would match graph number 1. So one way you can go about at least getting a clue of which graph would match would be to look at where the asymptotes are. Okay? Now, without a graph, what do? It says state the domain and the vertical asymptotes. Again, look at the denominator. If x is -2, right here, if that was a -2, that denominator would equal 0. So my domain then is x is not equal to -2, and the vertical asymptote is the x equals 2, and I think it's -2. It should be -2. Okay. Then, looking at number 5, that's a difference of squares, so that will factor as x minus 2 times x plus 2. So two values of x, if it's +2 here and if it's -2 here, if either one of those values occurs in the domain, then the denominator would be 0. So in this case, there's two values that cannot be in the domain. X can't be -2 or 2. Okay, so the vertical asymptotes are at x equals -2 and x equals 2. Okay. Now, if x is 0 here, doesn't matter if it's squared or what, then that denominator is going to equal 0. So my domain, x, is not equal to 0, and it has a vertical asymptote at x equal 0. All right, on number 7, we can factor out an x, and we're left with x plus 3. So again, there's two values that could make this denominator equal 0. If x was 0 or if x was negative 3, either way, then this denominator would equal 0. So two values are not in the domain, so x is not equal to negative 3 or 0. And it has two asymptotes. One of them is at x equals 0, and the other one is at x equals negative 3. Okay. And two more. We're going to factor number 8, and that will factor as x plus 3 times x plus 1. So the two values of x that would make this denominator 0 would be if it is either negative 3 or negative 1. So from the domain, x cannot be negative 1 or negative 3. And vertical asymptotes, x is equal to negative 1 and x is equal to negative 3. Now on this last one, we're going to have to factor by grouping or trial and error. Grouping's better. So we multiply. Yes, I'm sorry, I had it turned down.
Oh my God, we've been trying to reach you guys. Ms. Raimundo says she needs relief people.
What do you mean? We need to send somebody there or what?
No, we don't have any extra relief people. People are going home sick. As far as my relief people, can y'all cover each other for lunch?
Oh, sure. I don't see why we can't. So you don't need one of us to come there. You just need us to take care of our lunch here.
You could do that. That would be great. And Ms. Ramirez is on her way over there, but that means there's no one here for the restroom. So if y'all could take care of that, I would really appreciate it.
Okay, I'm sorry. I had the volume turned down. I'll just send her back then.
Thank you.
Okay. Okay, so there was a little brief interruption there. So we go from, we multiply to be 2, we multiply 2 times negative 3, and we get negative 6, and our middle term is negative 5. So we need two numbers. Alright, so we need two numbers that will multiply to be negative 6, add to be negative 5, which would be negative 6 and 1. And so then you can use grouping. Split the middle term, so you have 2x squared minus 6x plus x minus 3. The negative 6 and the positive x take place in the negative 5. Factor out the greatest common factor, which is going to be 2x. And that leaves me with x minus 3. There's no greatest common factor there, so put a 1 in front. So now we know the two factors, and they are 2x plus 1 and x minus 3. That means the two values that would make the denominator 0 are negative 1/2 and positive 3. And so we go over here, and from the domain we have to eliminate negative 1/2. It can't be that, and positive 3. And so our two vertical asymptotes are those same numbers as a line. X equals 1/2 and x equals 3.